So today we will discuss about permutation and combination. For example, we have set with n elements. Here is set and there are n elements. And hopefully you remember in the set does not matter ordering of elements. And we have here set of n elements. And for example, we want to this n element put in particular order. So in particular order, I mean, we have here n slots. And we should put this n element in particular orders. Any possible ordering of an element, it's called permutation, and we will denote it by P and N. Any possible ordering of n elements. Also, in some textbooks, they are used symbol. So it means this is permutation of n elements. How many permutations we have here? In the first slot, we have n choices. In the second slot, we have n minus 1 choice because one element we already used to put in the first slot, and so on. In the last element, we have one choice, and now we will use product rule, what we discussed in previous class, and by product rule, our permutation, it equals n times n minus 1 times n times 1. And you know that it's called n factorial. So permutation of an element, it's n factorial. Now, hopefully you remember what is number of subsets of set of n elements. Number of subsets of set of n elements. What is this number?
2 to the power n.
Very good. This is 2 to the power n, and we proved it by induction. Now we can prove it by combinatorial reasoning, and our reasoning is the following. So here we have an element. In the set, we have an element. And for any element, for all elements, we have two choices. Put in the subsets or not. So for an element, we have two choices. Two choice for one element, two choice for second element, and so on. Two choice for last element, and here we have an element, and using product rule, this is 2 in the power n. So we know now what is permutation of an element. This is n factorial. And also we defined what is permutation. Permutation is, let's repeat again, permutation, it's any possible ordering of n elements, n factorial. And also we know number of all subsets of set with n elements. Okay. But now we will interesting. We have again set with n elements. And now we will interesting how many subsets with exactly k elements we can choose. So here is an element, and we know number of all subsets. All subsets we mean beginning from empty set with one element, and so on, set with an element. And we know that number of all subsets, this is 2 in the power n. But now we are interesting. What is number of subsets with exactly k elements? This is called combination of n elements, of k element of an element, and it's denoted by, we have different symbols in different textbooks, and we will denote it by C and K. It also can be denoted as NK and also as NK. So let me emphasize again, what is CNK? This is number of subsets with exactly k elements. Okay, so we don't know what is this number. We know very well what is number of all subsets, but we don't know what is this number. But despite it that we don't know how to calculate this number, I denoted it by this symbol. Okay, now on the other hand, for example, I have again set with an element, and I need to, I have here k slots. I have here k slots, and I need to put k element from this set in particular order. So we know that if I had n slot, as in previous example, all possible ordering, it was n factorial. But now I have here n element, but here I have not n slots, but k slots. How many possible ordering we have here? In the first slot, we have n choices. In the second, we have n minus 1, because we already put first element in the first slot. In the second, we have, in this third slot, we have n minus 2, and so on. And what will be number of choices in the last slot? So this is first slot. Here we have n choices. This is second slot. We have n minus 1 choices. This is third slot. We have n minus 2 choices. And what is number of choices in the last slot? We have all.
N.
Yes, Elena?
N minus k plus 1.
Oh, very good. Very good. N minus k plus 1. Common mistake here is n minus k, but indeed, I agree with Elena. We have n minus k plus 1, because in the second slot, we have not n minus 2, but n minus 1 choices. Okay, so now we will use product rule, and number of all choices, number of all possible ordering of k element from set of n element is going to be n times n minus 1 times n minus k plus 1. Now, this product I will write in different view for my purposes, and you just should look critically and agree with me or disagree. So I will write it as n factorial divided by n minus k factorial. Please look very carefully and tell me if you agree or not. So, for example, I can do it.
I do think in my homework last night, I did think that factorial would be something to use here. Yeah, I think that looks right.
Okay, thank you, David. And I can give examples for numbers. For instance, 5 factorial divided by 3 factorial. 5 factorial divided by 3 factorial. 5 factorial I can represent as 3 factorial times 4 times 5 divided by 3 factorial. So here we have 4 times 5. So this same we can do here, n minus n factorial, we can represent as n minus k factorial times n minus k plus 1. This is next integer, next integer of n minus k to n factorial. Okay, let's write it in details. This is here n minus k factorial, and n factorial I can represent as n minus k factorial times next integer. And what is next integer for n minus k? Next integer for n minus k integer, it's n minus k plus 1. And so on, n. Okay, so I will erase it. So we agreed that this is correct. Now we remember that k element from n element I can choose in C and K ways. I don't know what is this formula, but I denote it by C and K. At the same time, C and K I can describe as number of subsets with k elements, with exactly k elements. Okay, now so how we got this number n factorial over n minus k factorial? We took here from this set of n elements, we put k elements in particular order. Now I will do it in different ways. First, I will choose k element from this n element. I will choose k element, and then I will order these elements. So I know this symbol in how many ways can I choose k element from this n element? This is Cn times k. And then this Cn times k, I have here Cn times k. And now this k element, what I already chose, this k element, I will arrange in particular order. So I should multiply it by k factorial. Now I can equate this expression with this expression, and it's going to be Cnk times k factorial equals n factorial divided by n minus k factorial. Any questions about this? So this number, n factorial divided by n minus k factorial, I obtain in two ways. First way, we imagine that here we have k slots, and this number we got that how many possibilities are here to order k element from an element. And this is number of these permutations. On the other hand, first, we got the same number in two stages. First step, to choose k element. And for this, we have C and k ways. And then these k elements order. Here we have unordered elements. You know very well that in the set elements are not ordered. And from here, we can order this k element, and we got the same number. And from here now, Cnk equals n factorial divided by k factorial times n minus k factorial. Okay, now let's say again, what is this number? This number is number of all subsets with exactly k element. Now let's check how it works, this formula. For instance, imagine that k equals 1. K equals 1. K equals 1, what it means? We are looking for number of subsets with one element. And what is number of subsets with one element? I don't mean to put in this formula. I mean by understanding what is the subset. So we have set with an element, and my question is, without looking to this formula, my question is, what is number of subsets with one element?
Same n.
Yes, of course, it's n. It's n, of course. For example, if we have set with two elements, A and B, what is the number of subsets with one element? This is 2. Subset with one element. This is A and this is B. So in general, here we have What is this number, Salome? Cn1, I mean, Cn1. Cn1. I mean, what is this number based on combinatorial reasoning, not according this formula, but according combinatorial reasoning. What is this number? This number is n, because we have set of n elements and number of subsets with one element, it's n. Now let's check by this formula. And in this formula, we have n factorial divided by 1 factorial and divided by n minus 1 factorial. So 1 factorial, it's 1, it's obvious. N factorial divided by n minus 1 factorial, it's n. Because n factorial, I can represent as n minus 1 factorial times n. Any questions so far? Any questions?
No.
Okay. If no questions, I have next question. And my next question is, what do you think? What is S N N?
One.
So Elena thinks that this is 1. Elena, why do you think that it's 1?
This is the number of how many subsets it will be with n elements. So if
Okay.
it's all n elements, then it will be just 1.
Yes, absolutely. Very nice explanation. Very nice explanation. So we have n set of n elements and number of subsets with n element, it's 1. Okay. Now let's check this formula, how it works. And I will rewrite this formula here. Snk equals n factorial divided by k factorial times n minus k factorial. Okay, let's check how this formula works. And Sn it's going to be n factorial divided by n factorial and times n minus n, 0 factorial. 0 factorial. What do you think? How this formula works?
0 factorial, I don't understand why, but 0 factorial is 1. So it would be n factorial over n factorial, which would equal 1.
Oh, very good, David. And 0 factorial, by definition, it's 1. And that's why is this definition for this formula to work. Because without this definition that 0 factorial is 1, we have no this formula. Okay, now what C n of 0? What is C of 0? I mean, by understanding, by combinatorial reasoning, what it means, C of 0. Andrew, are you here? Andrew Mazmishvili?
Maybe the empty set in this case, so it will be 1.
Yes, very good.
Again?
It's not, it's number of empty sets. It's number of empty sets. And you know what is number of empty sets? This one. And also we can check this formula works also well because 0 factorial it's 1. Okay. Now I have now one question. What do you think? What is this sum? Cn of Cn of 0 plus Cn of 1 Cn of 1 plus and so on plus Cnn. So if you are genius in algebra, you can replace Cn of 0 Cn1 by formula, use this formula of combination, and sooner or later you will get right answer. But you can avoid these messy calculations by being more clever and find this sum by understanding what it means.
Maybe it will be all subsets of n, because we're just, so it will be 2 to the power of n. Maybe.
Oh, excellent, Salom, excellent, very good. In fact, we have here sum of subsets with 0 element, with 1 element, and so on with an element. So here we have number of all subsets, and we know what is number of all subsets. It's 2 in the power n, and we have this formula. Okay, any questions? Now, I would like to ask you to download from the module week 13. I uploaded the file. This file's name is Permutation and Combination. And please download this file. And meanwhile, I would like to ask, for example, we have 10 people, and we need to choose 3 people to form committee. What do you think? How many ways are there? So we have 10 people, and we need to choose 3 people to form a committee. How many possibilities are there to form committee?
We have to use formula. In this case, it will be like C 10 3, and if we calculate, it will be like 120.
Okay, Elena, it's almost good, and almost because I'm not formulate this problem completely, because it's matter in this committee all these people are equal, or there is chair of this committee, deputy chair, and third person. So it does matter. These people are equal in this committee, or they are first person, second person, and third person. Okay. And your answer, Elena, I guess it's when all people are equal. So we need to form committee, and if we need to form committee when all people are equal, we can translate this problem in the set language. This is, in fact, this is mathematical modeling. And this problem in mathematical model, we can translate as how many subsets in the set with 10 elements, how many subsets are there with exactly 3 elements. And this is C 10 3. Okay, let's calculate it. So it's 10 factorial divided by 3 factorial times 7 factorial. So it equals 10 factorial. I can represent as 7 factorial times 8 factorial times 9 times 10, and 3 factorial, it's 2 times 3, 7 factorial, and 7 factorial, I can cancel. Also, I can cancel, I can divide by 2. I have here 4, 1, 3, and our final answer is 120. Any questions about it? Do you agree?
Yes, I get the same answer when I calculate it.
Okay, very good, Elena. Now,
I have a question, but in this way, the order doesn't matter, yes?
yes, because all people, Salome,
Yes.
it's very important, because all people in this committee, I told that all people in this committee are equal. So
Okay.
it means that order does not matter.
Okay, thank you.
Okay. Now, let's now, we need to form committee with 3 elements, but there also we need to choose chair of this committee. So we should choose first person, second person, and third person. What can we do in this way?
We have to use the first formula, 10 factorial over 10 minus 3 factorial. So it will be
yes,
720.
we can use this formula, and also we can do this problem without any formula. So here we have 3 slots. In the first slot, we have 10 choices.
Yes, 10 times 9 times 8, yes.
And here we have 8 choices. And product of these numbers, it will be all possible permutations. So 9 times, and what is this number? This, it's going to be
720.
720. Okay. Also, we can use formula of permutation, k element of an element, n k, and it's going to be 10 factorial divided by 10 minus 3 factorial, and we will get the same answer, 720. Okay. Now, I would like to emphasize to be very careful when you use this formula. And when you need to use this formula of permutation, you can use this way, and also you can use formula. But when you need to find unordered set, when you need to find set with exactly k element, it's hard to do it without formula. And you should use this formula of combination. But you should be very careful because it's confusing sometimes. And there should be clear understanding what we have. To use this formula of combination, we must have that find number of subsets with k element. Find number of subsets with k elements. If it's not clear, we should find other way to solve this problem. And sometimes I recommend to solve problems with formula only in case when you have clear understanding that you should find number of subsets with k elements. In other cases, you don't need to use formula, and you can solve problems by understanding and by sum rule and product rule. Okay. Now let me give another problem. For example, we have two lines. And in the first line, we have 4 points. And in the second, we have 3 points. Okay. What do you think? How many lines can we pass through these points? So how many lines? I mean, for example, this line, this line, this line, and also this line, this line, this line. How many possible lines?
12.
I think it's very good answer, 12, because we don't need here to use this formula, because here is clear that for every point in the upper line, we have 3 choices. And we have here 4 choices, and answer is 4 times 3. Or vice versa, from any point for a line which lies below, we have for any 3 points, we have 4 choices, and we have the same answer, 3 times 4. Okay. Okay. Now, let's now have this same 2 line with these same points, the same number of points. But now, question is now how many triangles we can construct with vertices at these points. For example, I will show one triangle. This is one triangle. Also, I can show another triangle. Okay, and question is how many triangles we can construct?
Is it 30?
Jacob, I don't know exact answer. I don't know exact answer, but I know how to solve it. But let's help us to solve it. What is your idea? How you got this number?
I actually remembered the answer. It was in one of the exams, I think. I didn't solve it, I just remembered the answer.
So now let's think how to solve it.
I think we should use C formula where n is 7 and k is 3.
Salome, say again, please.
We should use the formula, C formula, where n is 7, because we have 7 points.
Okay, which formula we need to use? What do you think? Which formula? So now, first of all, we should translate this problem in the set language. And in fact, what it means, construct triangle. Construct
She
triangle.
said C formula.
Yes, correct, Georgi. How can we translate it? In fact, what it means to construct triangle. To construct triangle, it just means to choose 2 points from these 4 points, to choose here 2 points. And how many ways are there to choose 2 points from the 4? This is C42. But it's not enough for triangle. For triangle, also we need to choose 1 point from the 3 points. And we know it's possible in 3 ways. It's obvious, it's clear. However, I will write it in combinatorial formula 3, 1. And using product rule, I will multiply it. So it's correct. It's correct, or do you have any different? Or do you have any different idea? Any
I
different?
think it's correct.
Any other idea?
We have more choices too. We can choose 2 points from the second line and 1 point from
Oh,
the first
Salome,
line.
I can't hear. Unfortunately, I can't hear you. So it looks correct. It looks correct. But we just missed that also. But this is only case when in this line A, we choose 2 points and 1 point we chose in the line B. But also we can choose here 2 points and 1 point in the line A. So we missed this case, and this case will be C32 times C41. And what will be total number of triangles?
Some of them. We have.
Yes, some of them. And I like this example. I like this example because here we use both product rule and sum rule. And it's clear that here we should use here product rule, and then we should sum these numbers. Okay. Okay, next problem. It's about handshake. Have you heard about this problem? How many handshake in the room?
Yes, I think in the school.
Okay, so problem is that in the party there are n people, and how many possible handshake? If you know definitely that one person handshake to other only once. Or we can formulate this problem like in the room there are n people, and we know definitely that all of them handshakes to each other exactly one times. And how many handshakes are there?
N times n minus 1 over 2.
Say Jacob again. N times
N times n minus 1 over 2.
n times n minus 1 over 2. Could you explain it?
I just remember formula. I didn't know the explanation.
Oh, so
I can explain it.
okay, Salome, please.
It's true. It's right. It's true. I think so. So we take one person. There is left n minus 1 person. Yes, in the
Very
room.
good, very
So
good.
one person is. So this is why we have n times n minus 1, and we divide it two because when one person shakes to another person, it means that both of them have shaken their heads. So we do divide.
Very good explanation. Very good explanation. So I agree with it, but now I want now to translate this problem in the set language. And what do you think if I will translate this problem in the following view? How many subsets with two elements have set with n elements? So I want to formulate this problem like this. We have in the set, we have n element, and how many subsets with two elements are there? Is this problem the same? Because my explanation is that handshake, I consider as subset with two elements. So I choose two people, and in this set language, it means that I choose subset with two elements. Because in the handshake, as well as in the subsets, order does not matter. And I claim that we have, I translated it correctly, that I have set with an element, and I need to choose, I need to find how many subsets with two elements are there. What do you think? Is it correct, my translation? So in my case, answer, it will be Cn2. And you can check, we will have this same answer. Let's check n factorial divided by 2 factorial times n minus 2 factorial. And I can simplify it. N factorial I can represent as n minus 2 factorial times n minus 1 times n, and 2 times n minus 2 factorial. So I have the same answer, n times n minus 1 divided by 2. Okay, my next question. For example, here is cycle. And in this cycle, we have 1, 2, 3, 4, 5, 6, 7 points. Question is, how many triangles we can construct? How many triangles we can construct? Try to translate this problem in the set language. What it means triangle in the set language.
Subset with 3 elements.
Very good. It just means that we need to choose subset with 3 elements. Very good, Georgi. So construct triangle. To construct triangle, for example, here we have A1, A2, A3, A4, A5, A6, A7. So to construct triangle, for example, I constructed this triangle. It means that I choose 3 dots. I choose 3 elements. So our problem we can solve using combination, and it's going to be C 10, 3. Any questions? Okay. Now, please open this our file, permutation and combination, and look there, find there in the last page. No, it's not last page. There are 9 pages, and this is page 8. And find there number 33.
Is it in models? Because I cannot see it.
Yes.
Find it also.
Oh, maybe I did
think
not.
it is not.
Maybe I did not publish. I will check. Maybe I did not publish. I will check now. Just a minute. Just a minute. Oh, yes, it's not published. Sorry. I published it now. Now you can see it. Permutation and combination.
So 33, right?
Yes, 33. Okay, 33. So in the department, there are 10 men and 15 women. And how many ways are there to form a committee with 6 members if it must have the same number of men and women? So the same number, I guess the same number, it means 3 men and 3 women, because there are 6 members. So if there is not indicated, we assume that all members of committee are equal. So we have 10 men and 15 women. And how many ways are there to form a committee with 3 men and 3 women?
We just use the C formula and write 15, C15 3 times C10 3.
Plus, I
15.
think.
So we all agree.
Times.
Oh yeah, times.
So we all agree that we can choose. We use here formula for combination because all people are equal. In general, it's a very nice phrase. All people are equal and have right to be free. C15 3. And women, we can choose C10 3. And now question is, we should multiply, we should use sum rule or product rule?
Product rule.
Yeah, product rule. We should multiply.
Product rule, I agree, because when we use product rule, when task can be broken into steps, into stages, we use 3 women and 3 men. Okay, very good. Okay, now in this file, find number 8. Number 8. What is your idea? How can we solve it?
I factorial.
In how many different orders can 5 runners finish a race? If no, yes, it's just 5 factorial. I agree. It's ordinary permutation of 5 elements. Okay. No. Okay. Now look to number 11. This is about bit string. So how many bit strings of length 10 contains exactly 4 ones? So we have a bit string, and we can imagine that we have
Sorry, which exercise is this?
11. And in
Okay.
the 11A, exactly 4 ones. So bit strings, you know, it's string which contains zeros and ones, and we are looking for a number of bit strings which contains exactly 4 ones. So one of these is 1, 1, 1, 1, and 6 zeros. Okay. What do you think? Any idea how to translate this in the how to translate it in the set language?
C10 4, I think.
Oh, maybe, Georgi, maybe. And can you explain?
No, it's just my intuition.
So we can these slots we can just number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the length of string, and we know that here is exactly 4 ones. So we have there only 2 digits, 1 and 0. So we have here exactly 4 ones. I can translate it as choose from this set, choose 4 slots. So we have 10 slots. In other words, now I will say it in the set language. We have set of 10 elements, and here we should choose 4 elements. And what it means to choose 4 elements. For example, if I will choose 4 elements, 5, 4, 5, 9, 8, 9, and what it means? It means that here will be 0, 0, 0, here will be 1, 1, 0, 0, 1, 1, 0. So I hope you agree with Georgi,
Yes.
with me, that we can translate this problem in the set language, that from the set with n elements, in how many ways we can choose subset with 4 elements. Okay, but so let's first agree with Georgi. This is C10 4. Okay, but what happens if I look to this problem from the other view? And so it's given that there is exactly 4 ones, but at the same time, it means that there is exactly 6 zeros. So I can look to this problem from the other hand, from the other view, and how many bit strings are there with exactly 6 zeros. how can we solve it? In the same way, And answer in this case,
Is equal to C10(6).
answer in this case is C10(6). And Jacob is right that don't confuse about it. These two numbers, they are the same. And by combinatorial reasoning, we can conclude it from this reasoning. And as for formula of combination, I can write it C10 for it's 10 factorial divided by 4 factorial by 6 factorial, and I have here the same. Here we have this same C10(6). It's going to be 10 factorial divided by 6 factorial times 4 factorial. So they are the same. Okay. Okay, at most for once, what we will use here, at most for once, it means that this bit string can contain no one, only one, only two ones, only three ones, and only four ones.
We have to use sum rule, I think. C10(4) plus C10(3).
Very good. So in this case, our answer will be sum of this 4 cases or 5 cases.
5 cases.
How many, Georgi?
5.
4 or 5 cases, because it's starting from 0, when we have 0, 1, when we have exactly 1, and when we have 4, 1. Okay. Any questions? If any questions? Okay. Now, number 13. Number 13. It's about men and women. In the group n men and n women, how many ways are there to arrange these people in a row if the men and women alternate?
N factorial times n factorial.
I think it's a good idea. I'm not sure it's correct or not. Let's discuss about it. But so Georgi's idea is that it's n factorial times n factorial. So I guess Georgi's reasoning is that there is n men and we can arrange them in n factorial ways, women's in n factorial ways, and then we use product rule. Okay. Any other idea, or maybe you would like to express your opinion about it?
I just thought to do it different way. So we know that men's and women's can be in some. We have some n number of men and women. Yes.
Yes.
So I just combined this men and women. So it was n times n, and then I understood that there will be to arrange. There will be n over two ways to arrange this combination of men and women.
So, Salome, what is your answer? I will write here.
I don't know answer, but I think I thought that to combine men and women. So we may have combination of men and women n times n. Yes.
So let's, for example, we have 3 men and 4 women.
Yes. We can combine them. So we have to so I just combined them. So I wrote 3 times 4. So I made combination. How many combinations there can be with men and women?
These women are different,
Yes.
and let's denote it
Yes.
by A, B, C, D, and let's denote by this man by X, Y, Z. So, Georgi first arranged these men's. So X, one of the possible permutations, X, Y, Z. Oh no, there is the same number, not n factorial and n factorial, but they are the same numbers. N men and n women. Yes?
Right.
Yes.
They are the same numbers, yes. So here is the same numbers, n factorial and n factorial. So this is one of the possible combination here, A, B, C. So X, Y, Z, there is 3 factorial permutation. It's obvious, definitely. Also for A, B, C, there is 3 factorial combination. And so by using product rule, there is 3 factorial times 3 factorial. Georgi,
Nice.
do you think the same, or do you have any other opinion?
No, this was my opinion, right?
It's very close. It's very close. It's very close. But here is case when first is men. But also we should consider when first is a woman. And that's why this answer, we should multiply by 2.
Right.
Okay, let's finish for today. And see you after tomorrow.
Goodbye.
Bye.
Bye.
Bye.